What we're doing right now is we're looking at how to simplify polynomials, how to make them look simpler. And it's kind of funny, we're going through this in 8th grade, Algebra 1 Honors, we're going through polynomials, how to make them simpler. And I'll do this if you come to my 8th grade class next year. I probably won't do it this year for you guys. I had them teach the lesson. They taught the lesson, they went through the notes, they put stuff on the board, they asked questions. And I sat there as a student and I asked my own questions. Some of them were easy, some of them were not. But some of their classmates were rough. Why do you have to simplify them? I'm like, ugh. The only reason I know is because I know what's coming up. They're like, we'll talk about that later on. And so that was their answer. We'll talk about that in a future lesson. Good, that's a nice cop-out. But why do I want to simplify this? Do you like things a little... Oh, I'm not even going to answer. Go ahead, Alex. Oh, I saw that answer.
Make it easier on yourself.
It makes it easier for me to look at. It makes it easier for you to look at. And it makes it easier for us to work through. Okay, how many terms does this expression have as of now? How many terms? Lift the fingers up for how many terms that expression has. 3 terms. Okay, how many of you are tempted to say a 3-term polynomial is a trinomial? Trinomial, right? There's only one little problem with this, now double finger, trinomial. It's really not a trinomial. It's more of a something else. I can't use the quotations. All right. I'm going to underline the terms. Are there any like terms? Like terms, right?
3x to the second power and 12x, negative 12x to the second power.
Very good. 3x to the second power and negative 12x to the second power. Why are they like terms? One of them is positive, one of them is negative. That doesn't make them like terms. One's at the beginning, one's at the end. That doesn't determine like terms. What makes them like terms? All of you have to be able to figure this out.
The variable is the same. It's the second power.
Good. Both of them have x to the
Second power.
second. Because don't they all 3 have x?
Yeah.
But they're not all 3 like terms. Please don't forget that. I don't know if you're look at number 39. Oh, they're all like terms. Just group them all together because they look the same. Well, they may look the same at a glance, but they're not like terms. Yes, they are not like terms. Okay. All right, what is now, CT, I'm going to have you answer this. Ready? What is 3x squared plus negative 12x squared?
Negative 11? No.
So 3x squared plus negative 12x squared. Or let me simplify it. What's 3 plus negative 12? 3 plus negative 12. Or 3 minus 12.
Which way? Negative 15.
It's negative 9. And listen, this is something I saw in that test. 3 plus negative 12, I got negative 15 a lot. Was anyone tempted to say negative 15 on this? Okay, if you weren't, that's good, but some of you were because I saw it. You did it. What's a positive plus a negative? How do you work that out? You take the bigger absolute value, which is 12, subtract the smaller one. That's how you get your 9. And then which sign do I keep? The bigger absolute value, which is negative. Don't forget that. Now, when you combine those together, did anything change with the exponent or variable? Did you get x to the 4th? No, x squared. That's it. But poor old 7x, what happens to it?
Stays the same.
It stays the same. There are no like terms. This is a simplification of the original. Why is it simplified? Because instead of 3 terms, how many do you have? 2. And I don't know, but I hope my math is right. 3 is more complicated than 2. That's just, I don't know. I think I'm teaching Ezra that. This is more than that. This is a little bit easier than that. Just a little bit. Okay, what is it classified as now, Aiden?
Binomial.
Binomial. So you write binomial. So that's what they want you to do in that section. How many of you kind of understand what's going on? How many of you kind of want to figure this out on your own? Awesome, all of you do. I saw those hands. Number 40. Go ahead and do that one. Number 40. add like terms and then classify it according to its number of terms after it's been simplified. Number 40. Do you have an answer? Okay, sure. Yes. Yes, ma'am.
Those together since there's technically more for that.
Yes, sir. Have an answer? Is it this one or this one? This one. This one. Okay. Yes, ma'am. Okay. Oh, did you call it? Call what it's classified. Simplify it and then call it monomial, binomial, trinomial. Yes. Oh, so who else had it? I hope so. Let's figure it out. All right, here we go. How many like terms? How many? I'm almost giving it away. How many pairs of like terms?
Two.
Two. One pair. And this is what I do for myself. So and some people, they circle like terms and then they box other like terms. Whatever it takes for you to keep them together. All right. A squared minus 3a squared. Huh? There's a number in front of that a squared.
One.
What's that? Sorry? Yes, there is one number in front of that.
It is the number.
Yes, there is one. That is correct. Not two, but one number.
And the number is 1.
One. Yes, there are one and only one number. That is.
And the number in front of that number variable is the number 1.
I guess how many there were.
Oh, that's what you guys meant. I'm so sorry. Okay, all right, all right. So what's 1a squared plus negative 3a squared? Alec, what's 1a squared minus 3a squared or 1a squared plus negative 3a squared? Negative 2a squared. How many of you got that? Good. Day, what is a squared b squared plus 4a squared b squared?
5a squared b.
Now, how do I write it? Because I'm kind of confused. Like, do I just write 5?
No, plus.
What? Plus?
Because there's an addition sign.
Uh-huh. All right, like that?
Yes.
Oh, okay, yeah, I got you. Okay, what's positive 1 a squared b squared plus 4a squared b squared? That's hard to say. Positive 5a squared b squared, right? Positive 5a squared b squared. All right, that's my simplification, and you guys should know it as a binomial. Man, that's easy, right? You guys get that. Does it stay that easy, though?
I don't know.
39. You may begin. I only need, since one just left, I have 18, I don't know, 17? 17 of you to get it right.
Sounds not wrong.
No, one wrong. Only one wrong. Yes. Oh, something's after my job. I don't feel uncomfortable. I don't feel very comfortable right now with that statement. Edit this swivel. Cut that out. She didn't say anything.
What would you do?
Math?
2 plus 2 is 7.
No, 2 plus 2 is fish.
Bird.
Which Ezra will never forget. Ah, I gotta drill that out of him.
That terrible child.
That terrible child taught your child how to.
Who can do this for me? Actually, I'll ask Ben. Can you read the problem for me, just the way it's written, so I can write it up here?
17 p squared r squared
was that it?
Yes.
This accomplishes what?
Thanks, Ben, for giving me time to write it. Appreciate it. Now, okay, how about that?
Actually, that wouldn't matter though.
Why? Because of the
Something.
commutative property. Wait, I thought it was commutative property of addition. You got a bunch of subtraction going on up there. What can you make subtraction problems into? Addition. And that means you can move things around. Yeah, so even if you read it backwards, as long as you gave me the correct signs, we should have been okay. Please check that I wrote this right, because if we didn't, this is bad. Like if I put one little exponent of 2 where it didn't belong, or didn't put it where it belonged, it's all bad. Tell me? Yeah, sorry.
Wait,
I need to know.
that's right.
17p squared r squared plus 12p r squared minus 4p squared.
An addition.
Yes, right here. Thank you. That's what we wanted. By the way, I worked this whole problem out with that little switch. I get the answer right for that problem, but they wanted it this problem. So, anything else? Or forever hold your peace in mind. And I only get embarrassed on online TV.
Online.
Yeah, YouTube TV, they got me on there now. I don't know. If you watch me, yes, maybe.
Really?
No, I don't know.
You
I don't
can't go
check
on
it.
YouTube TV.
Oh, you broke my dreams. Okay.
No, that's like cable but cheaper.
Just be
And it's a lot better. than-
Very true.
Yeah.
It is really good.
Okay, Marshall, give me any sets of like terms.
17p squared r squared and
Actually.
and negative 4p squared r squared.
Okay, that's a set. Do I have another set?
The door just opened.
I close it.
I think Ethan just took off for a little bit. He'll come back. He'll close it. Thank you, Danny, because that was semi-scary.
What's locking out?
It's next to
But Danny, give me another set
Um,
of like terms.
12p r squared and negative 13p r squared.
Okay, and then does 4p squared r have any like terms with it? No. So you still deal with it, just not. What's 17 minus 4? 13p squared r squared.
Wait, what?
These two right here.
Oh.
What are these two combined? You could say negative pr squared or negative 1pr squared. Doesn't matter. And then 4p squared r. It didn't have to look like this. How many of you have it 13p squared r squared plus 4p squared r minus 1p r squared? You switch terms around. Are you allowed to do that? Yeah. Did anyone not have this first? It's usually common. Did anyone not have this second? You just reverse those. As long as this is positive, that's negative, it's fine. We like that. Yes, sir.
So you could have done negative 1pr squared plus 13p squared r squared plus 4p squared r.
Yes, you could. Yep, exactly right. Now, there's only one problem with that. You can get a bunch of different answers from that, right? So there's got to be some kind of standard way of doing it. I hope there is. Monomial, binomial, trinomial. 1, 2, 3, we call it a trinomial. And that's it. You guys get that? I want to move, I'm going to go one more type, because this is one that continues to get us. 2b times b minus 4. It's in there and it's actually worked out for you, but we're going to work it out together. It's number 37. Okay. I have technically here a monomial times a binomial. Do you guys see that? It's a monomial times a binomial. I'm okay with saying that? No confusion there? I can say that because it's 2b. Well, actually, this is going to get away. What's going on between 2b and b minus 4? What's that operation? Multiplication. But you're multiplying with two terms. So what property must be applied now? Distributive. All right, so I'm going to do 2b times positive b And 2b times negative 4, negative 4. Did I emphasize the negative?
No.
Okay, what's 2b times b? 2b squared. Are you allowed? Okay, do you guys notice that these are technically these are like terms, right? You're allowed to multiply them, but you can also, please listen carefully, you're allowed to multiply unlike terms. You're allowed to do that. You just can't add and subtract unlike terms. Okay, what's 2b times negative 4? Well, first of all, are those like terms? No, but can you multiply them? Yes. What's positive 2b times negative 4? Negative 8b. Okay, can you combine those two terms together? No. That's as simple as it gets, right? That's the simplified form, and it's therefore a binomial. Ma'am?
Why is it b squared?
Oh, yes, because you had a b times a b, so I have two b's being multiplied. That's literally what you mean there, which is nice. Here I only have one b being multiplied, so b to the first was right there. Don't forget, guys, what exponent's right up here? 1. A 1. Technically, there is. Okay, last one I'm going to have you guys do is number 42. Oh, we didn't even see who got that last one right, huh? Okay, we're going to do this on 42. I want to have 10 people getting it right. 10. 42. 42 is the last one for this lesson. We'll move on to the next with the degree of a polynomial. This is review of the last chapter. In fact, it's part of your last test where I had you do this kind of work. Please don't add first.
Can you combine like terms before you do the distributive?
According to order of operations, can you do that?
I don't know.
No. So you want to do what's in the parentheses first. If you can't do that, then you do what's outside. All right, technically, if these were all just numbers, wouldn't I have to do this first? Yeah, but I can't because they're not all numbers. They're numbers and variables. So what do I have to do now? All right, how many of you thought you could just add these two together? Never think that. That's what I want you to never think that. It's always this first. If not that, then you get to handle that. What's 3 times p?
3p.
Positive 3p, yep. What's 3 times 2pr?
6p.
Positive 6pr. Positive 6pr. And then that 24pr comes in. So any like terms? Yep, the first and the last gets me my 30pr plus my 3p, which gets me a binomial again. Guys, do you realize that binomials are very common? They're more common later in this chapter, and it means something. It's good because we like binomials, we can deal with them. Trinomials, that's actually my favorite number, is 3. So I like them, but you may not. Okay, yep. Is it emergency? Please go.
You guys see how many people got right?
Yes, thank you. Okay, put a thumb up on your desk if you got it right.
Oh yeah, even was.
It's okay, yeah, he's good. 16 of you. Oh,
Wow.
that shattered that record.
Wait, how many were you counting out of? Wow.
17, I think, because 2 people were gone.
Yay, so we did get.
So we got the right.
Hey, we got it.
We got
Good
the right
job.
That's the first time.
That's like the first time ever.
That was the introduction to the actual lesson. All right, Swivel, goodbye.